Hey everyone, welcome back to my YouTube channel. What if everything you thought you knew about our solar system was wrong? Imagine a world so massive, so distant, so utterly hidden, that it has remained a ghost for centuries, a silent puppeteer pulling the strings of distant icy bodies, bending the very fabric of our cosmic backyard without ever revealing its face. You're talking about a world potentially 10 times the mass of Earth, a super-Earth, or perhaps a mini-Neptune, lurking in the deepest, darkest reaches of our solar system. An unseen titan whose gravitational whisper reaches across billions of miles to shape the destiny of everything beyond Neptune. This isn't science fiction. This is the tantalizing, frustrating, and utterly mind-bending reality that astronomers are grappling with right now. For decades, we've charted our solar system, from the scorching plains of Mercury to the frigid, icy realms of Neptune. We thought we knew our cosmic neighborhood, a neat collection of 8 planets, a few dwarf planets, and countless smaller objects. But what if there's a ninth, colossal player, a hidden monarch whose existence is only hinted at by the strange, inexplicable dances of objects at the very edge of our perception? How can something so immense, a world larger than our own, remain elusive, a phantom limb of our solar system, influencing everything we see without ever being directly observed? This impossible question has haunted astronomers for generations, a cosmic paradox that demands an answer. The implications are staggering. If this unseen world exists, it redefines our understanding of planetary formation, the very birth story of our solar system. It challenges our models of gravity and opens up the possibility of other hidden giants in other star systems. It's a mystery that touches upon our place in the universe, forcing us to confront the vastness of our own cosmic ignorance. Prepare yourself, because we are about to embark on a journey to the very edge of our known universe, peeling back layers of scientific discovery, frustration, and eventual revelation. It will uncover the bizarre clues, the desperate search, and the cutting-edge technology finally peeling back the veil on what could be the biggest secret our solar system has ever held. The truth, as always, is stranger than fiction. But to understand this cosmic mystery, we need to go back to where it all began, to the very first whispers of an unseen world. Our story begins not with a bang, but with a wobble. For centuries, astronomers meticulously mapped the heavens, but it was in the late 18th and early 19th centuries that things started to get really interesting. In 1781, William Herschel discovered Uranus, a magnificent blue-green gas giant. This was a monumental achievement, expanding the known boundaries of our solar system. But as astronomers tracked Uranus over the decades, they noticed something peculiar. Its orbit wasn't quite right. It wasn't following the path predicted by Newton's laws of gravity and the known masses of the other planets. There was a persistent, subtle deviation, a tiny tug that couldn't be accounted for. It was as if an invisible hand was gently nudging Uranus off course. Imagine the frustration. These were brilliant minds, working with the most precise instruments of their time, yet their calculations simply didn't match reality. The discrepancies were small, but they were undeniable. The prevailing theory? There had to be another planet, an unseen giant whose gravitational pull was responsible for Uranus's anomalous behavior. This hypothetical world became known as Planet X. Two brilliant mathematicians, Urbain Le Verrier in France and John Couch Adams in England, independently set about the arduous task of calculating where this unseen planet must be. It was a monumental feat of celestial mechanics, a cosmic detective story played out on paper. The tension was palpable. Both men worked in isolation, racing against time and each other, poring over reams of data, making incredibly complex predictions. Finally, in 1846, Le Verrier sent his calculations to astronomer Johann Gottfried Galle at the Berlin Observatory. On the very first night Galle looked, within half an hour of starting his search, he found it. A new planet, exactly where Le Verrier predicted. It was a triumph of human intellect and observation, a testament to the predictive power of Newtonian physics. This new world was, of course, Neptune. The solar system had expanded again, and the mystery of Uranus's wobble was solved. Or so they thought. But then something unexpected happened. As astronomers continued to observe Neptune, they realized that its asterisk orbit also showed slight irregularities. Not as pronounced as Uranus's had been, but still there, a persistent hint that something else was still out there, beyond even Neptune. The search for Planet X was rekindled. The idea was that Neptune's mass, combined with the gravitational influence of another, even more distant body, would explain these tiny discrepancies. This time, the search would be even more challenging, peering into the even darker, colder, and more distant reaches of space. This quest would lead to the discovery of Pluto in 1930 by Clyde Tombaugh at the Lowell Observatory. For decades, Pluto was hailed as the ninth planet, the long-sought Planet X. But as our understanding of Pluto grew, especially with more precise measurements of its mass, a new problem emerged. Pluto was tiny, far too small to exert the gravitational influence needed to explain the orbital anomalies of Neptune. It was a beautiful discovery, a testament to human perseverance, but it wasn't the Planet X astronomers were truly looking for. The cosmic mystery, far from being solved, had only deepened. The ghost remained. The subtle tugs on the outer planets were still there, unexplained, hinting at a much larger, much more profound secret lurking in the blackness beyond our current vision. The hunt for the asterisk real Planet X was on, and it would lead us down a rabbit hole of even stranger discoveries. The investigation into our solar system's outermost mysteries truly began to deepen in the late 20th and early 21st centuries. After the realization that Pluto wasn't the massive Planet X, astronomers found themselves facing a baffling puzzle. If it wasn't Pluto, then what was causing these persistent gravitational anomalies? The search evolved from simply looking for a single, large planet to meticulously mapping the vast, icy expanse beyond Neptune known as the Kuiper Belt. This region is a cosmic junkyard, home to millions of icy bodies, dwarf planets, and comets, a relic from the early days of our solar system. As new telescopes and techniques allowed us to peer deeper, we started finding more and more objects in the Kuiper Belt. Eris, Haumea, Makemake, these dwarf planets, some nearly as large as Pluto, began to populate our cosmic maps. But here's where it gets weird. While discovering these new worlds was exciting, it didn't solve the Planet X problem. In fact, it introduced a new, even more perplexing mystery. As astronomers charted the orbits of these distant Kuiper Belt objects, or KBOs, and even more distant extreme trans-Neptunian objects, or ETNOs, a strange pattern began to emerge. Their orbits weren't random. They weren't scattered haphazardly across the vast emptiness. Instead, a significant number of these distant icy worlds seemed to be clustered together, their orbital paths strangely aligned, as if they were being herded by an unseen shepherd. Imagine a flock of sheep, all moving in the same general direction, even though you can't see the dog or the shepherd. That's what astronomers were seeing. The orbits of these ETNOs, objects like Sedna and 2012 VP-113, shared striking similarities. Their perihelia, the point in their orbit closest to the Sun, were all clustered in roughly the same direction, and their orbital planes were also tilted in a similar fashion. This wasn't just a coincidence. The statistical probability of such an alignment happening purely by chance was incredibly low, like rolling a dice 1,000 times and getting the same number every time. This was a clear pattern, a cosmic fingerprint pointing to something massive, something unseen, influencing their paths. This bizarre clustering became the strongest evidence yet for the existence of a true Planet X, now often referred to as Planet 9. The theory is that the immense gravitational pull of this hidden giant is shaping and sculpting the orbits of these smaller, distant objects, effectively corralling them into these peculiar alignments. Think of it like a giant magnet influencing iron filings. The filings align themselves according to the magnetic field, even if you can't see the magnet itself. In this case, the ETNOs are the iron filings, and Planet 9 is the unseen magnet. But the investigation didn't stop there. Scientists also looked at the tilt of the entire solar system. The plane of the 8 known planets is tilted by about 6 degrees relative to the Sun's equator. This tilt is another long-standing mystery. Remarkably, recent studies have suggested that the gravitational influence of Planet 9 could also explain this tilt, providing another piece of the puzzle. It's as if this hidden world isn't just affecting distant objects, but has subtly influenced the very architecture of our solar system since its formation. The complexity grew as researchers began running increasingly sophisticated computer simulations. They started to model different scenarios. What kind of planet would be needed to create these observed orbital patterns? How massive would it have to be? How far out? The models converged on a fascinating picture. A world roughly 5 to 10 times the mass of Earth, orbiting the Sun at an average distance of about 500 to 700 astronomical units. That's 500 to 700 times the distance between the Earth and the Sun. To put that in perspective, Neptune is only about 30 AU from the Sun. This would be a truly distant, truly dark world, taking perhaps 10,000 to 20,000 Earth years to complete a single orbit around our Sun. This isn't just about finding another rock in space. This is about rewriting the textbooks, about fundamentally changing our cosmic address. The scientific community, once skeptical, began to take the Planet 9 hypothesis very seriously. The evidence, though indirect, was compelling. The clustered orbits, the solar system's tilt, the sheer statistical improbability of these phenomena occurring by chance, all pointed towards a hidden gravitational architect. But how do you find a world that's so dark, so distant, and moves so slowly? That, my friends, is where the modern quest truly begins, pushing the boundaries of technology and human ingenuity to their absolute limits. The biggest revelation, the direct observation of this unseen world, is still out there, waiting. The modern quest to find Planet 9 is a testament to human ingenuity and the power of cutting-edge technology. With the indirect evidence piling up, the challenge shifted from proving its existence to actually finding it. This is where telescopes like the Subaru telescope in Hawaii, and more recently, the Vera C. Rubin Observatory, formerly known as the Large Synoptic Survey Telescope, come into play. These instruments are not just bigger, they are designed for wide-field surveys, capable of scanning vast swathes of the night sky with unprecedented speed and depth. Search strategy is akin to looking for a single, incredibly dim needle in an unimaginably vast haystack. Planet 9 is predicted to be so far away that it would reflect very little sunlight, appearing as a faint, slow-moving point of light against the backdrop of billions of stars. Astronomers are looking for something that moves against the fixed stars over several nights or weeks. But even with powerful telescopes, the sheer volume of data is immense, requiring advanced algorithms and supercomputers to sift through it. However, the Planet 9 hypothesis isn't the only game in town. There are other compelling, and frankly, mind-bending, theories attempting to explain the orbital anomalies. One of the most intriguing, and perhaps unsettling, is the idea that the gravitational influence isn't from a planet at all, but from a primordial black hole. Yes, you heard that right. Black hole, but not the monstrous stellar mass black holes born from collapsing stars. Instead, a primordial black hole, formed in the earliest moments of the universe, perhaps no bigger than a grapefruit, but with a mass similar to that predicted for Planet 9. Imagine that. Our solar system could have a tiny, invisible black hole as its outermost member. The appeal of this theory is that a black hole would be incredibly difficult to detect directly, perfectly explaining its elusive nature. While it wouldn't emit light, its gravitational effects would be identical to a planet of the same mass. Scientists are exploring ways to detect such an object, perhaps by looking for gamma-ray bursts or gravitational lensing events if it passes in front of a distant star. It's a truly wild card in this cosmic detective story, forcing us to consider possibilities far beyond conventional planetary science. Another theory, though less favored for explaining the specific clustering, is modified Newtonian dynamics, or MOND. This theory proposes that gravity behaves differently at very low accelerations, which might explain some anomalies without needing extra mass. However, MOND primarily addresses galactic-scale rotation curves and has difficulty explaining the very specific localized orbital clustering observed in the Kuiper belt. Then there's the possibility of a massive, extended disk of smaller, icy objects, perhaps tens of thousands of them, whose combined gravitational pull could mimic the effect of a single large planet. While this is an intriguing idea, current models suggest that the total mass required for such a disk to produce the observed effects would be enormous, making it difficult to reconcile with the overall mass budget of the outer solar system. The scientific battle of ideas is intense, with each theory having its proponents and detractors. The Planet 9 hypothesis, however, remains the leading contender due to its ability to elegantly explain multiple observed phenomena. The clustered orbits of ETNOs, their similar inclinations, and even the overall tilt of the solar system. The continued discovery of more ETNOs with similar orbital characteristics further strengthens this case. Every new object found that fits the pattern is another clue, another breadcrumb leading us closer to the truth. The climactic revelation will come when, or if, Planet 9 is directly observed. Imagine the moment. A scientist, poring over a new image from the Vera C. Rubin Observatory, notices a faint, slow-moving dot. Further observations confirm its motion, its predicted orbit, and its gravitational influence. The sheer awe of such a discovery, to finally lay eyes on a world that has been a ghost for so long, would be unparalleled. It would be a moment that transcends science, touching upon the very human desire to explore, to understand, and to chart the unknown. We are on the cusp of this discovery, perhaps just years away from rewriting the map of our own cosmic home. If Planet 9, or whatever unseen world is out there, is finally confirmed, the implications for humanity's place in the universe are profound. It means our cosmic backyard, a region we thought we had largely explored, still holds colossal secrets. It suggests that our understanding of planetary formation and migration might be incomplete, forcing us to reevaluate how solar systems evolve. Massive planets so far out could have dramatically influenced the early bombardment of the inner solar system, or even the delivery of water and organic molecules to early Earth. It's a missing piece in the puzzle of our own origins. This discovery would ignite a new era of exploration. Imagine future missions, robotic probes venturing billions of miles beyond Neptune on a multi-decade journey to this frigid, dark, and utterly alien world. What would its atmosphere be like? Does it have moons? Could it harbor conditions for some form of exotic life, warmed by its own internal heat or geological processes? These are the existential questions that would follow, pushing the boundaries of our scientific curiosity and technological capabilities. The search for Planet 9 is not just about finding another celestial body. It's about expanding our cosmic imagination. It reminds us that even in our own solar system, there are still vast, uncharted territories, mysteries waiting to be solved. It reinforces the idea that the universe is far more complex and surprising than we often give it credit for. Upcoming observatories, like the Vera C. Rubin Observatory, with its unparalleled sky mapping capabilities, are specifically designed to find such faint, distant objects. The next decade promises to be a golden age for outer solar system exploration, a time when the veil on these unseen worlds might finally be lifted, forever changing our understanding of our cosmic home. The anticipation for these future discoveries is immense, a testament to our enduring human drive to explore the unknown. We began this journey with an impossible question. How can something so massive remain hidden for so long, influencing everything we see without ever being directly observed? We've traced the whispers of its gravitational pull from the anomalous wobbles of Uranus